During a recent live stream, one of my cohorts in the Manx Beard Club decided it would be funny to swap some neons between different containers. So he put some green neons into the blue or vice versa. And rather than test them all individually afterwards, I decided to crack out this device called a neon tube tester. And the neon tube tester is basically a high voltage sort of, I suppose in a way it's RF sort of levels, but it generates a high voltage output in the antenna. And if you put it into a container here, actually, you know what, I'm going to turn the light off. I'm going to take the exposure off, and I'm going to turn the light off here so you can see this. If I hold this next to the tray of neons and I push the test button, it will make them all light up. So you can see that those are all pretty much the same colour in there. Okay, what about this tub here? So those are more or less sorted out. That's good. Oh, actually, no, I can see the blue one. I can see the rogue blue one. I shall just fish that one out and test it on its own. And to test on its own, all I need to do is hold the leads, and I can put this near it, and that little neon will light up just with the RF energy being emitted from this unit. Okay, I shall put these neons out the way. I'm going to bring the light back, but I tell you what, I'm going to pause momentarily just to put these out the way before I end up dropping them and mix them all up again. One moment, please. So this device here is a sort of, it's a toolbox type device that is designed for people who work in what's left of the neon signage industry. And the instructions that come with it, I'll just read you the first bit. Say, Neon Tester Instructions. Overview. Welcome to my factory production of TS-990 type neon tube tester. It is a science and technology with the latest development and production of modern neon tube detector. Use neon tube test equipment for testing when a card is not bright neon lights. Immediately pinpoint the reasons for maintenance, thus improving work efficiency. Neon tube tester is powered by batteries, so easy to use, simple, small. Neon maintenance work is essential for good helper, so that's perfectly logical. It says it takes 4 AA batteries, but the polarity must be correct. But the downside is that the only indication of polarity in this is actually on this back cap. There's nothing really obvious here, and it's not like the contacts at the end are identical. So it's worth mentioning if you get one of these, that the polarity is marked in this. In this case, the positive is pointing up over in this direction. And it does take 4 AA cells. The output head in contact with electrode wires, neon tubes. Hold down the power button this time, LED indicator light flashes, and the test tube. Precautions, hand touching output head antenna. Cannot press the power button to avoid electric shock and danger. Well, let's test that for a start. To avoid actually getting a zing and a burn, actually I'll do it to the wires. Right, so I'm holding the wires here in my fingers, and I'm going to bring this antenna up to it and I'm going to touch it. And you may or may not see that a little spark is drawn onto the wires. I shouldn't get a shock, but I might get a shock. You can hear it, but you can't really see the spark, can you? It is pulsioned off and current's flowing through my body, but I'm not getting a shock. The whole point of this is that if you hold, well, you're not supposed to hold the wires, but I'm going to hold the wires. I have got exposure off. Hold on. Let's try that. Let's lock the exposure. Is this a good idea? I'll test this, see how bright it's going to be. It's making the whole tube light up, but the tube is actually lighting by passing current through my body to the other electrode. In use, because it will find other routes to ground, you can theoretically just reach up to the sign that is not powered, and you can touch the wires like this, and you'll see it's glowing just with the RF discharge. In fact, if you put it in the middle, you'll probably see there is a very faint glow, just with the excitation of the gas by the antenna there. It's an interesting device. What else is worth mentioning in here before I open this up? Not much. Okay. So it keeps mentioning a strong shock. I will say this, if you put it up to your skin and you draw an arc onto the skin that's good at pulses, because the older ones didn't flash on and off, it will draw an arc and you'll end up with wisps of smoke coming off your finger from the point it burns. It's more likely to be a stabby, burny pain than electric shock. In fact, theoretically, I could just hold this, right, and just pass the current right through the body. What am I going to get? No sensation. It's passing a lot of current, it's passing enough to light the tube, but I'm not getting the shock because it's doing it capacitively at very high frequency. Okay, Right, I'm going to put this tube out the way before I damage it, because it's so hard to get tubes like that. I'm wondering now, there is an interesting thing. What would happen if... am I going to regret this? Am I going to regret this? I might regret it. If I put my finger in the back of this and touch this little ozone plate, what's going to happen? Not a lot. No ozone. Right, I had to do it anyway. It was just a little test. So yeah, these were sold in the UK, not just to the neon sign industry, but the electrical distributors also sold them on the pretext that, you know, you could, instead of, if you were a facilities manager operative, you could test fluorescent tubes and troubleshoot light fittings by just reaching up, touching the fluorescent tube, and it will make the tube glow. However, that was just pointless because it doesn't really narrow the faults down too much. It could be the starter that's faulty, but quite often a tube will not light if, say for instance, the ballast is faulty or the heater at the end, the cathode, has actually gone open circuit. That it's not a greatly useful tool. However, in the neon sign industry, where you had a tube, they tend to have seals on them. I'll bring that tube back in. Here is the seal where the vacuum is drawn and then it's tipped off. It's that little pip there. And it's very common for them to just get either pinholes there, or it can actually, where the wires go in, you'll also get failure. And if a tube allows the vacuum, if the vacuum fails and air gets into the tube will stop working. And if you've got loads of letters along a sign in series, that's where this came in really useful. You could actually go around all those letters and test them and see which ones didn't light, although it did kind of require a fairly dark environment to do so. But very useful tool. However, let's open it up. Out come the batteries, and I have to say that I think this thing is glued together. Right, tell you what, let's try some techniques for opening it. Stuff the pliers in, open the pliers up like that. Ow, 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 it's pinching my fingers. This is working. It's open. What do we have? Rightio, there is the high voltage transformer. It's all potted. I wasn't expecting that. I thought it was going to be more open. Here's the antenna at the side. Right, this is all hot melt glued in. Even the battery terminals are hot melt glued in. Right, tell you what, give me one moment. I'm going to explore this a little bit further. The reverse engineering is done, and oh wow, this circuit should be lit with neon because it is so retro, but in a good way. Those of you who are into such things as the older circuitry will recognise the NE555 timer chip, and you might spot something that looks suspiciously like a stable multivibrator. Let me show you the back of the circuit board if you want to try and reverse engineer this yourself. Unfortunately, there's some tracks hidden under here, but this is one side. And there's the other side, flipped, so that, you know, everything matches up. So for instance, chips here, chips here. Let me spot a couple of things. Big transistor, there's the primary of the high voltage output transformer. Let me show you the transformer. Oh, there's a circuit board error as well. There were two pads here that they wanted the LED to be mounted over the side, but the LED, they actually accidentally brought the negative connection to LED instead of the positive connections as it should have been. A little design error, that's okay. The transformer is interesting. Here's the circuit board here. The transformer looks as though it's been potted in a little, almost like a little paper box. And it's a very chunky transformer, but it is fully resin potted. It's got a very long winding in relative terms of 30 windings for the primary. Well, I say that, and it's long in terms of these style of transformers. And at the other end, you can just see the little sort of stripy effect because it's got the multi-section secondary, the bobbin, so that they can wind the windings in multiple sections because it operates at very high voltage. It's notable that one of the connections comes out right next to the primary connections, though it's not directly connected to it, but it's at a similar potential because it goes to the negative on the circuit board. But the other one has been kept well away from those windings. It's been kept right in the corner of this because that is the high voltage output. And it's worth mentioning that this is basically a high voltage transformer operating with a floating output. It's almost like it's using this antenna to capacitively couple through glass or connect onto connections, but then the capacitive coupling return is through you holding the unit, and the batteries are actually capacitively coupling through the case to your hand at that high frequency. And that puts a lot of stress in these transformers, so the construction of them is really important. They have to be really well potted. That was most likely vacuum potted. I don't see any hint of bubbles at all in it. And it's a bit rhombocidal, just because it has been potted in, basically speaking, a little cardboard box. That's quite neat. Cardboard box. Right, let's take a look at the schematic. Oh, this is not going to have any surprises for you. Here is the schematic. I shall zoom up just a tiny bit more so we can take a look at this. I've divided it into two sections. The first is a classic astable multivibrator commonly used to alternate between two LEDs and various other purposes. It's using 2N2222A or 2N2222A transistors and a symmetrical pattern of components, 15K, going to the collector of the transistor, and then 100K for the timing to the capacitor going to the other side of the capacitor here, which, when this is powered up, they'll basically toggle backwards and forwards. When they do that, two things happen. It flashes this LED, and that's the one that actually had one of the connections down to the negative instead of the positive. That's why they had to jump at the wires during manufacture. That must have annoyed them. There it is with its two little wires. That was actually designed to just go straight on the circuit board. But the output also goes to the 555 reset pin, and that means that the 555 is basically being turned on and off, and it operates at very high frequency. Let me show you the 555 circuitry. Something worth mentioning about the 555. The date code in this, if this is the date code, 1819, it's manufactured in the last year or two. That is staggering because the 555 is one of the oldest chips. It goes back to 1972. That is that's one of the first integrated circuits. It's approaching its 50th birthday in 2 years. That's really spectacular. If I've got my arithmetic right there. The 555 it's a modular system. I could show you the picture. Hold on. Texas Instruments to the rescue. Texas Instruments datasheet shows a rough image of the inside, and what you're seeing here is you've got the positive supply, and it goes through a resistor which acts as a basically current limiting, then it goes to the control voltage, which is a little capacitor to ground, and it creates a fixed voltage reference. And from that, well, it creates a fairly... The voltage reference will vary according to the supply, but it will be divided by this chain of resistors. And that's just that little tap there with the capacitor is just for stability. But it has a couple of resistors that give a couple of voltage thresholds, and it's got two sensors, the trigger sensor and the threshold sensor, and then a flip-flop which can be switched between on and off state effectively and drives the output, which can actually sync and source a lot of current, which is important in this case, out pin 3. That's why the 555 is such a famous chip. It's so popular because it's super versatile. It can cover really low frequency, really high frequencies, and it can drive a lot of currents. You can drive speakers and lamps and big arrays of LEDs, and it can, by alternating the polarity at an output, you can actually toggle backwards and forwards between two channels of LEDs, like, say, for instance, a police set of light with their red and blue LEDs. So in this instance, we've got the batteries here for the supply. We've got the push button on the negative that could have gone anywhere that supplies power to the circuitry when you push the button. The 555, when it's enabled, because at that point that you push the button, it powers everything up, including that flip-flop. But the flip-flop is connected to pin 4 of the 555, which when you pull it low, holds it in a reset state. It's normally, in most applications, pin 4 is just tied to the positive rail along with pin 8. I didn't write pin 8 next to that one. I should write pin 8 next to that one. And pin 1, which is the ground, is actually pin 1. So this thing, when this is enabled, this capacitor, this real low value 2.2 nanofarad capacitor, charges up via these two resistors. And once it reaches a threshold voltage that's connected to the two sense voltage levels, it changes state. The output will turn on, and it will also enable this discharge transistor inside that actually then discharges the capacitor to ground via this resistor until it reaches another voltage level, and then it resets and it starts again. So it's alternately charging and discharging this capacitor, and that's one of the quirks of the 555 in this format, is that it's always, when it discharges, it's going to be the 5K1 resistor, but when it's charging, it's going to be the 300 plus the 5K1. So it skews the timing, it biases it in one direction. The sort of output polarity, the Mark space ratio. The output of this, which is now toggling at high frequency, there's a little 10 nanofarad decoupling capacitor. I'll show you that in the schematic in a moment. It goes via a 270 ohm resistor, and it drives this BDT63C NPN transistor, a very standard transistor, and that switches the primary winding in that transformer, this sort of little hefty 30 turn winding. And that, I tried measuring it, it's less than an ohm, it's much less than an ohm, so it's like pretty much impossible to measure. With a standard meter, you'd have to go for a super low meter more suited to testing low resistances. The capacitor, the 2200 microfarad capacitor, this one here, is directly in the vicinity of this transformer because it's to deal with the fact that it is switching very high current spikes. It makes sense to have the decoupling directly in the vicinity of it. So this coil is being pulsed at very high frequency thanks to the 555. It's also being gated on and off by the flip-flop just so it does continually flash the output. And the output then, this winding, which is a impedance of 1000 ohms, well, a resistance of 1000 ohms, that generates the high voltage, and one end is just tied to the 0 volt rail, so it gets that nice ground reference through the battery pack and you holding the case. And then the output on the antenna is just the high voltage from that. I'm not sure what voltage it is. I would say probably about 5 kV actually, because you could draw a fairly decent spark. Although having said that, maybe it's less, because once you've drawn a spark, it's actually easier to sustain it. Maybe 3 kV. Quite a high voltage though, at very high frequency. So the components on the board, the decoupling capacitor here, for the supply to give it a stable voltage reference, is this little red capacitor here, and this little green capacitor here is the 2.2 nanofarad, and the resistors are just buried in here. Oddly, the resistors for setting the timing, one is at one end of this stack of resistors and one is at the other end. It's a very straightforward circuit. It's very retro circuit, very old-fashioned indeed. It's what it used to be the circuit you'd find in electronics magazines in the 80s. Very strange. But very functional, and it's clear from the circuit board that it has been given a rework. The date in the circuit board is 0903-2003. So it's been given a rework, say 17 years ago. That's recent by my standards. But there we go. Interesting little unit. As I say, not great for testing for electricians as such, but great for people working on neon signs, although ultimately the demand for neon signs is lesser these days. But an interesting device, and also quite fun just as a novelty for exciting tubes and playing about with, because the way it can actually couple from the tube to your hand and make it sort of glow without giving you a shock. Slight burn, but not a shock. Very interesting little device. I like it, so well worth getting one and taking it to bits. I always really wanted to know what was inside one of those, and now I know. Slight delay, and then we check, have they gone yet? Have the normal people gone before we talk about the other use for things like this? This is basically an RF jammer. This, not in the sense of jamming RF signals, but it puts out very high voltage RF energy. And if you hold this unit and you go up to some electronic equipment and hold it in the vicinity of it, and they used to make boxes that did this with petrol pumps and petrol stations, which doesn't sound like a good idea, or the gaming equipment, if you hold this in the vicinity of the machine, and some of the jammers were actually based in little boxes, but with very similar circuitry, and the box basically had a piece of circuit board inside, or foil covering one side for capacitive coupling, and you'd place it in certain parts of the machine, it would crash the processor in the machine, or induce voltage in places that the voltage shouldn't have been induced, like the coin inputs, and it would do things that give free credits or crash the machine or cause it to pay out and things like that. So they had other naughty uses. I'm not sure how that would work these days. They tend to be wise to such things, and certainly After they discovered things like this were happening, the fruit machines, they actually put antenna wires in them. And if you go up and you try jamming it with one of these, it will actually set off an alarm and the fruit machine shut it down. So that's something worth mentioning, that these high voltage units at high frequency can be used for nefarious purposes too, as electronic jammers.